Hi friends, welcome back. Today we're talking about triangle congruency by hypotenuse leg. Corresponding parts of congruent triangles are congruent, also known as CPCTC, and we're talking about overlapping triangles. So to get started, go ahead and write this down in your notebook, and if you haven't already, please be sure to copy down some of these notes that we've been talking about. Okay, so what we're going to do first is JK is congruent to LK. So JK is congruent to LK. We want to mark that down. That's a given. And then KM is perpendicular to JL. KM is perpendicular to JL. So that means a perpendicular line creates right angles, right? So as far as our notes go here, definitions, this would be a good one. And in fact, we should probably add it to our notes. If you see perpendicular there, we have to give a definition for that. So that means that to angle KMJ and angle KML are right angles. Right angles. And that is the very definition of a definition of perpendicular angles. So we can say definition of perpendicular angles. Okay. So now that we know that, the hypotenuse leg is where we have the hypotenuse of a right triangle and a leg, then we can say that these two right triangles are congruent. So the next thing that we want to do, actually, because we're saying this about the right angles, we also have to say that for number 3, KMJ, it's not just enough to say that they're 90-degree angles. We also have to say that they are congruent. So KMJ is congruent to KML. And this is because for number 3 here, all right angles are congruent. So all right angles are congruent. Okay, now that we have that, we need a leg for our hypotenuse. And if you go through our checklist here, you'll see that we have like the definitions, and then obvious but not givens are vertical angles, parallel line relationships, reflexive property, and I see a reflexive property right here. We can say that on this guy for number 4, we've got KM is congruent to KM, and that is because of the reflexive property. Okay, at this point I have shown now that I have a leg and a hypotenuse on two triangles that are congruent. On two right triangles that are congruent. So what I can say is triangle JKM is congruent to triangle LKM because of hypotenuse leg. Hypotenuse leg. Excellent. Okay, let's try another one here. So on this guy. Okay, so for this one we are told SV is congruent to UT. SV is congruent to UT, and ST is congruent to UV. Okay, we need to prove that angle S is congruent to angle U. This is a little different because like we've been doing on all so far, we've just been proving triangles are congruent. We're still going to stick to that method. Now, so that means for number 2 here, we're going to say, I don't have any definitions to do, but I have an obvious but not given, which is that my VT is going to be congruent to TV. VT is going to be congruent to TV, which is the reflexive property. Reflexive property. Okay, so now at this point I have, if I were to separate these triangles out, you see that I would have 3 sides that are congruent. Therefore, these triangles have to be congruent. So now is the time to say, okay, triangle VST, and notice I went to the 1 dash, then the 2 dash. VST is congruent to triangle TUV. And again, I went the 1 dash and then the 2 dash. So TUV. And that is because of side, side, side. Now, we are not done with this. We have to prove that angle S is congruent to angle U. Angle S is congruent to angle U. Well, we've said that these two triangles are congruent. Therefore, those matching parts of those triangles are also congruent. So we can say that angle S is congruent to angle U because corresponding parts of congruent triangles are congruent. So corresponding parts of congruent triangles are congruent themselves. So therefore, angle S has to be congruent to angle U. Okay, one more that we've got here. So for our next guy, this one. All right, we have for, given that TU is congruent to, and let's start by doing this. Okay, given that TU is congruent to, or I'm sorry, T is congruent to U. T is congruent to U. I'm gonna mark that on these. You'll see that I separated out the triangles as well. Sometimes that's helpful when they're overlapping. Angle X is congruent to angle Z. So this guy is congruent to this guy. And then we have XY is congruent to ZY. So this is congruent to this. And again, XY, ZY. Okay, so at this point, we can prove these triangles are congruent. But what we're trying to do is prove angle WYZ is congruent to VYX. And so if we look at on this guy, here's our W here, WYZ. So we're trying to prove, and I'm going to put this in pink here. We're trying to prove that this guy right here is congruent to this guy. Okay, so let's take a look at this. So for our first one, obviously we put down our givens. Now this is one of those proofs that's not going to be, we're not going to go down our checklist completely, just because it's going to be a little bit different. So what we've got next is when we take a look at these, we see that TYZ is congruent to UYX. And that's what I was saying before was TYZ, let me write in my green, TYZ is congruent to UYX. So those triangles are congruent because of angle, angle, side. Remember, it's not angle, side, angle unless it's in the middle between those angles. So angle, angle, side. Now, because those triangles are congruent, those angles are also congruent. So I can say TYZ. So that's going to be, I'm running out of colors here. That's going to be this angle and this angle are congruent, right? So those two angles are going to be congruent. So we've got this guy right here is because corresponding parts of congruent triangles are congruent. So because we've proven the triangles are congruent, therefore those corresponding parts also have to be congruent. Now, what that means is because we have said these angles are congruent, we're going to be using the angle addition theorem, or angle addition theorem. So what we're doing is we're going to break down our angle. And in order for us to do that, we have to use the measurements. And if you have any questions about congruency versus equals, think of it like this. If I said Sam and Tom were the same height, that would be congruent. If I said Sam and Tom are both 5'11", that would be equals because we're using numbers instead of words. So we need to do that if we're going to be adding and subtracting things. So this measure of this angle is congruent to this measure of this angle because that's the definition of congruency. Definition of congruency. Okay, so the next part of this, as I mentioned, when you have overlapping triangles, sometimes it helps to use angle addition. So we're going to do TYW. So TYW, and in fact, if we use some highlighters here, that might help a little bit. Or maybe I just like colors, who knows. So TYW plus WYZ equals TYZ. So I've said this little angle here plus this little angle here equals this whole big angle. And we're allowed to do that because of angle addition postulate. So the angle addition postulate. Okay, now we can do the same thing for this other side, TYW. So TYW is congruent to, or I'm sorry, TYW, V, and then VYX. So TYW, VYX, that's this one. And then this guy right here is going to give us this total T or UYX. Okay, so we've got this angle. So we've got this angle, UYX. So what that really should have said is TYU. I'm sorry about that. So let's fix that guy right there. TYU. Or actually TYW would work because W goes all the way up to U. So that's totally fine. So we've got these two things. That's our angle addition postulate. Sometimes I do these and then I double check and I think I mix them up. Because like I said before, you know, there's multiple ways to do proofs. So one method, you might do one method and a classmate might do another. Okay, so let's take a look at the next part of this. When you ever use angle addition postulate or segment addition postulate, it's not a bad idea to just see if you can't create some, or do some substitution and then see if you can't create new statements or new sentences like this. So let's look at this for substitution. Well, if you look at these guys, we can say that TYW plus VYX equals TYZ. So you can see that I've taken this sentence right here and I've rewritten it, but I've replaced UYX and TYZ. I'm sorry, I have dyslexia, and so this is, if I state these letters wrong, I apologize. So UYX, TYZ. So we can do that. We're allowed to swap those guys out because remember back up here, we said, hey, the measure of these two angles are exactly the same. So all this is substitution property. Substitution. Okay, well now that we have this garbage equals this and this garbage equals this, we can say, hey, those two garbages equal each other, right? So we can say, all right, TYW, so this, I pointed to the wrong ones. This garbage right here, maybe it'll help if I highlight, this can be a lot. This guy right here and this guy right here, those both equal TYZ. So we can set them equal to each other. And that's what we've done down here are these two things. Now, what that really did was just knock out this like middleman, I call it. Knocked out this middleman. This garbage equals this garbage equals the same thing. Then let's just get rid of it and say that these two equal each other. Knocking out that middleman, that's the transitive property. Transitive property. A lot of kids get that confused with substitution. But if you can knock out that middleman, then it's transitive. Okay. So from here, I can see that I have TW. Now I'm just getting fancy because I want to use a different color. All right, so I got this TYW here. I can get rid of those on both sides by using the subtraction property. So if I say minus angle TYW on both sides minus the measure of angle TYW, I can be like, bam, bam, get rid of those. That's subtraction. Subtraction property. All right, so now what I've said is the measure of angle WYZ and the measure of angle VYX are equal to each other. But remember, I'm trying to prove that they are congruent. So instead what I'm gonna say is, all right, now because the measures are, then that means that they're congruent. Again, that's that definition of congruence. Definition of congruence. So when you're making, when you're dealing with triangles or angles or even segments, ask yourself, hey, if angle addition postulate would work, like can I take two smaller angles, add them together and get a big angle, and do that a couple of times and see then, okay, can I substitute something in and make a new sentence? And if I can I use the transitive property somewhere? Those are some good questions to ask for these. Hopefully you found this helpful. We look forward to seeing you next time.